Good morning, folks. This is lecture one of week 5, and it's pretty much the last lecture that I'm going to devote to assembly design. Okay, analysis of an assembly made with solid elements. Okay, so the on the agenda today there is the bolt tightening connection property, and there will be the actual generation of the bolt, and then the virtual bolt tightening connection where we don't need to generate the bolt itself. Uh, Now, the bolt tightening connection property, the first one comes under face-face connection, and the virtual bolt tightening connection comes under distant connection properties. If there is time left, I will actually go ahead and do the shaft bearing assembly that I made a crash video for you uh, on how to actually set it up, okay, but I didn't actually solve the problem if time permits. Uh, Now, the first problem that I'm going to do is actually out of chapter 17, and in a situation like this, we have two plates which are bolted together. So there is a bolt here. Now notice that I don't have a bolt, a nut at the bottom. And what that means is that this is viewed as screwed into, for example, the bottom plate. So we have the screw and the bottom plate is threaded, and this is screwed into the bottom plate, and therefore, basically putting the two plates together, pressing them against each other. Now, if I had a bolt, uh, actual bolt, there would be a need to do a nut down here, and the thread is going to be in the nut and the shank of the bolt, not in the holes. Okay, but basically, I'm doing a screw for you. Now, the pretension of the bolt is defined as 50 pounds, and the end faces are clamped. And after I do that, I see how things work out. Then I apply a force of 100 pounds at the face on the right side. Now, it is important to realize that uh, my request from you is never to cut through the bolt. Okay, so you have to use as many planes of symmetry that you have here. Obviously, here there is a plane of symmetry which is right across along the longitudinal direction, but that cuts through the bolts. So do not cut through the bolts, as you were asked repeatedly in the past. Never cut along the length of the beam. Okay, in the axial direction. Okay, good. And now the dimensions are given here, and I'm going to start making it top plate, bottom plate, and the bolt, which is really a screw. Okay, so let's start with the CATIA program. We start with the product file, All right, immediately save it. So file, save management, save as, desktop, new folder, desktop, new folder, and I'm going to call this thing chapter 7, bolt tightening, bolt problem. All right, so there we are. All right, so insert a new part in there. I'm going to call it the top plate, properties, top plate, scroll down, top plate. Okay, let's make it. On this plane, I will sketch a square 1 inch by 1 inch. I think those are the dimensions of the top plate. So let's do that. This is 1 inch by 1 inch. And there is a hole here. Let me see. There is a hole here of radius 0.125. Okay, exit and pad it up by, I think the thickness of those plates were also 0.125, 0.125. Okay, so this is the top plate. You go all the way to the top, insert, new part in there. Always say no, unless you have to for some reason. Properties, bottom plate, and bottom plate. Bottom plate. Let's make it. Double click on this. On that same plane, XY plane, I will sketch. This time a centered rectangle. We're going to fix this in a minute. So first of all, I want this corner control be coincident with this corner. Okay. And I want this length to be 2 inches, I believe. The length is 2 inches. 2 inches. Okay. And we want to circle that size. So if that's the case, why don't we project that circle anyways? If it's that size, then we just project it and exit, pad it in the opposite direction by 0.125. 0.125. And we say OK. Now notice that the holes line up. Okay. Go all the way to the top. Just in case things go wrong, I'm going to click on the floppy so that at least these two parts that I made are fixed. Okay, good. Now, I'm going to insert the bolt, insert a new part in there. So call it the bolt, right? Properties, more appropriately screws, because I don't have a nut, bolts have a nut, okay? So screw, I'll call it bolt. And bolt. And we're going to make it. Now, there are different ways of doing it if I want to be really lazy. So what I'm going to do is on that top plate, I'm going to sketch. Why don't I project that circle? Okay, exit. All right, and pad it. Bolt head, I'm told in the drawing that the bolt head is 0.1 inch. Okay. Then to do the shank, there are different ways of doing it. For example, I can, well, let me do the following. Let me hide this and hide that. And at the bottom, I sketch circle. Radius of that shank is the same as the radius of the bolt. So the hole. Sorry, the hole. So I'm going to make it exactly the same radius, but in reality, you know, remember there is a clearance between them. But I'm going to make it 0.125. Yeah, 0.125. Oh no, not 0.125. What was the rate? What was the radius of that hole? It was 0.125. So it's that head that is wrong. This head, the head I'm going to go have to fix it. Actually, let me cancel this. Let's exit. I made the mistake in the bolt head. So that would be right here, correct? Yeah. This radius should have been 0.25. The drawing says that the bolt head is, hang in there. There's some stuff that's not correct here. 0.125, these are correct. This is also 0.125. This is a mistake. this is the bolt head. It should be radius 0.2. That is a mistake. That should be 0.2. Radius 0.2. The diameter will be 0.4. Okay, so that makes sense. So this thing is going to be radius 0.2. Okay, and exit. All right. Actually, that was a mistake. Let's go here. Okay. This is correct. Bolt head. Yeah, bolt head. Okay, so exit. I really screwed this up. So let's see now. This is the bolt head. Okay, let's get these things to find out what's going on here. Let me get one of these. Yeah. So this is okay. So this is the shank, okay, and the bolt. Which one is this? Okay, that is the shank, and this is going to be the bolt head. So double click on that. I did that as 0.2. Fine. Man, I made this thing so hard. So the padded what is that? Bolt head is height of 0.1. Okay, good. Yeah, and this is going to be the shank, which is going to be all the way down to 0.4. Okay, wow, that took so long. So what's the situation here? Let's bring all of these into the show mode. Okay, so here's the situation. This looks fine, except that I kind of messed it up. So let's go all the way to the top. Okay, let us put some assembly constraint here. So anchor the base, the big plate, bottom plate, and then I move this thing up. I move this guy up. Okay, and right there, and I'm going to rotate it about for example, this about the x-axis. Okay, move it up. All right, good. Generally speaking, the shank of the bolt is not the same, of course, same as this thing, but I'm assuming that it's okay. This is always smaller than that, but I'll keep it like this, no problem. All right, so let's see now. Coincidence between this axis and that axis, and coincidence, oh, actually, let's update it. Good. And the coincidence between, for example, we can say this place, this face and that face, update. Okay, good. So here's the situation. This is what we've got. Everything is made out of steel. Please ignore anything that you don't like that I did. You have to create these three parts and put it together like that. So let's make it out of steel. Steel, everything out of steel. All right. Now, we're going to go into generative structure analysis. CATIA sees three solid parts and it meshes them one by one, three of them. Now, of course, you can refine the mesh and stuff like that, and I'm not going to do that, but you should be able, on the test, if asked, refine mesh in certain areas, etc. We have done it many times. The only thing I want to make sure that these are all linear so that I don't get any my computer going into state of coma. Okay, so that's okay. They're all linear. Now, first thing first, If you want to see, you can see the mesh. You can generate the mesh. I mean, basically look at the mesh if you want. Remember, we're not using symmetry because that requires passing through the bolt. So deactivate that horrible mesh. So we're going to clamp these ends. This end and that end, they're both clamped. And I know that the top plate does not penetrate the bottom plate. Okay, so we create the analysis connection between this top face of the bottom plate. And for the second component, I'm going to hide that. I'm going to make it bottom face of the top plate. And this connection that I created, because they can't penetrate each other, is going to be contact. So let's do that now. Okay, so contact. So where is that face-face connection property? Contact is the second one on the left. You click on it, you select that, and you say OK. Now, the bolt head cannot penetrate the top face, correct? So I need a contact, connection. Let me use the top as the first component, top face of this plate. And for the second component, I'm going to hide that and select the face, the face of the bolt head, right there. You can see that right there. Okay, and then we say OK, and this is also contact. So another contact for this. Good. Now, in principle, if I should say that there is contact between the shank of the bolt and the inside holes, but please realize that I'm not doing it. Okay, in principle, you have to create a connection between the face of the shank and the face of the bottom hole, make it contact, and the face of the shank and the face of the top hole and make it contact. I am not doing it, but if this problem was a test problem, you will need to do that. Okay, but I'm not doing it. Now, the final thing that we have to do, let me put this thing here. The final thing that we have to do is create a bolt tightening connection right there. You see that in the face-face connection property, there is an icon that says bolt tightening connection. What you need to do is to say, let me hide this. So if this is a screw, the bottom plate is threaded so that this actually gets screwed into that bottom plate. I need to create a connection between the shank of the bolt and the bottom hole, okay? The face of the bottom hole. So let's create it. Create a connection between the face of the shank, the bolt, right click, hide it. For the second component, select the bottom hole, okay? That's because that thing is going to screw into this, and this fellow, let me bring these into the show mode. Okay, I'll put this thing in the hiding. Okay. I want the bottom piece. Hide and show. Okay, there we are. Okay, good. So it created, this is a bolt tightening connection. So you click on this in the face-face connection property. The last constraint, the last connection that we made, face of the shank, or the shank of the bolt, and the face of the bottom hole. And now we're going to make it a bolt tightening connection. It is that last one that I did, and the tightening force is force. the tightening force is 50 pounds. Now, notice that it made a bolt for me like that, but the direction of it is wrong. If I wanted to model this bolt, this head should be on top. So instead of the same, see that the same? See the same? You make that opposite. So now you can see that the bolt head is on the top, and this is the bolt head. And we say, okay, good. Let's save this thing. File, save management. There's the analysis. Save as. This is the proper folder. Okay. Now notice that there is no load on the structure except for the fact that I use the bolt tightening connection property to actually tighten these two plates pressing against each other through that 50-pound preload in the bolt. So let's run it and see what happens. And it's done. So let's see how the deformation looks like. Remember, the ends are clamped. These two plates are pressed against each other through this bolt that we have tightened. So let's look at the deformation. That makes sense. First of all, let me just look at the ignore all those extra elements. So top plate, bottom plate, bolt. Okay, good. You can see that. So when you tighten this, because these are clamped, they get pressed. However, they bend. Okay. So if you look at the von Mises stress, for example, most of the stress is in that bolt. The bolt actually stretched because the torque that you applied and the threaded connection. So if you want to look at the stress in the bolt, just double click. Just show me the bolt, which is right here. I did not bother putting contact. I should have, between the face of this shank and the face of the top hole and face of the bottom hole, because I said that, well, this is going to stretch. So if it actually hits the sides and penetrates it, all this is just good looking color. That's all. It's all nonsense if that is the case. So I'm assuming that is not happening. Now, let's go ahead and get everything back. All right. Deactivate this plot, or either you can put it here. Deactivate it. Okay. Now we're going to put a 100-pound force at this face, because remember that was part of the problem. 100 pounds, I believe. Yep. So you apply a force on that face, downward, minus 100 pounds. So not only you tighten that bolt, but you also pressing this thing down. So now we're going to run it, and it's going to take both the load and this thing into account. Now, if you want to hide stuff, let's do that. Tools, what is that? Edit. I can't remember. It's here. I think it's hide, right? Tools. Where is the hide here? Let me see if I can quickly hide these planes. Yeah, right here. View, toolbars. Okay, so I want to hide these plates. Let me do it the long way. So I thought there was a quick hide and show, but the problem is that may be not in here. Maybe in the part or assembly design. So let me do it like this. Search in the part design, planes. Let me see if I have to get it from here. Planes, plane, right here. Find and search and find and hide. So this is a fast way for Hide. Just hide. Yeah, hide. A fast way of getting rid of those planes. Now, anyway, let's go ahead and look at the deformation. So not only these are tightened together, this is actually pulling down. Change the scale so that it's default. There we are. Change the rendering to the third one, which is shading with edges, and you can look at the deformation, this displacement. Because of that 100-pound, this is going to go down. You can see that, and change the rendering. Anything that you don't like, you can hide. So only show me the top plate, the bottom plate, and the bolt. Don't show me all that junk, which you can also hide from here. What is this? These are connections. There. And if you don't want this guy, let's hide it. There we are. And if you want to see the elements, edges, so you go there, which means the rendering, the very last one, question mark, and because this is already checked, it just shows you the element with the edges. Okay, and finally the von Mises stress. Again, change the scale, default. There we are. Okay. So what I'm going to do, the same problem, I can do it with virtual virtual bolt tightening. I can, but I'd rather go and well, actually, we can do that. We can do that. So let's do the following. I'm going to save everything here. Okay. So let's go to File Save Management. File Save Management. Now remember, this was all done in a folder which I called bolt tightening, correct? Let me go and take my product right there, save as. I go one level up, make another folder, and I'm going to say virtual problem, virtual bolt number 1, virtual bolt 1. So this product, I'm going to set it in, put it in there. But there's also this thing called propagate directory. Notice that in that folder that I created, this product is going to be there, but I want all the parts also come with it. Okay, so I'm going to say propagate directory and say okay. So in that folder, let's check it out. In that folder, which was called let me see now, virtual bolt 1, I have my product right there, and these parts, 3 of them. Okay, so let's go ahead back here. I don't need this analysis. I closed it, and this is the thing that I was in. I just saved it in. What I don't want to do is I want to get rid of that bolt. I want to get rid of that bolt. So let me do the following. Where is this bolt? I'm going to take it out. Literally delete it. Good. Okay. I don't have the bolt, but I want to solve the same problem. So first of all, we're going to go to generative structure analysis, just like before. Okay. There's no bolt. There's no mesh for it. And let me change the rendering here. Okay. What do we know? We know that these ends are clamped. Oops, not the edge, not the edge. These faces are clamped, just like before. And we create a connection. We create a connection because this cannot penetrate that with the top face of this bottom plate. Hide that. And the bottom face of the top plate right there. Okay, good. Where's the other guy? Let's bring it here. Let's bring this thing in the front. Okay, good. Now, this is going to be contact. We already know that. So let's go ahead and make a contact here, face-face connection property. This is the contact one between the top plate and the bottom plate. Now, I don't want to model the bolt, but I want to have basically model a virtual bolt or a virtual screw if you want. So I need to create a connection between, since I don't have bolt heads and all that stuff, between the top face of this and for the second component, the bottom face of that. Okay. Now this is going to be my virtual bolt tightening connection, which is, there's two versions of it. This is a more sophisticated version of it. There's the spring, says virtual spring bolt tightening connection. I don't want that. This is the standard one. I click on it. See that in the distance connection property, you click on it, you select it, and you put your tightening force. And this, notice that there is no option for us to flip these, and there's no reason to do that. When you do bolt tightening connection, it doesn't matter whether this thing that it puts here, the bolted is on the top or the bottom. It makes no difference. So when I run this thing, it looks as if I do have actually a bolt sitting there. It tightens these two. So let's go ahead and run it. Of course, I don't have a control over the bolt head size and things like that, but that may not be important. For example, when you do rivets and things like that, there are hundreds of these in a panel, and bolt head may not, or rivet head may not, size of rivet head may not matter. So let's look at this. You can see that just like before, except that, we don't have a bolt here. And if you look at let me deactivate that. You can look at also the stresses, change the rendering, material shading. Right there, we can see that. No bolt, but it's the virtual bolt. So let's deactivate this. Okay, so now I'm going to apply a force to that face. It was 100 pounds, and run it again. Notice that bolt was not actually modeled. It was a virtual bolt. So if you look at deflection, just like before. Now, we're not doing any mesh conversion study here. Therefore, these are just colors and numbers. We don't have no confidence in them. And one really has to perform mesh conversion study to find out what's going on. Okay, no bolt. Now, I want to go and do this problem, except that I will make up my own dimensions. So basically, it's two plates. There is a pressure vessel. These corners are fixed, clamped, and it has a cap. And in the cap, I have two holes, and I want to pressurize this. Okay. Yeah. So let's go ahead and do that. My own dimensions. Okay. So let's go ahead there. I'm going to get rid of these, and I'm not going to save anything. Let me first go ahead and make the container, the bottom, the gray piece container. So product, we say OK. Insert in there. This is going to be the container itself. The cap, I'm going to call the cap. So let's make it on this plane. I will sketch something like that. I'm not using any symmetries. If you were to use symmetry, you just use it this way, not that way, because that way cuts through the bolts. Okay? So if you were to use all planes of symmetry, just cut it like so. But I'm not using it. Okay. And another one. Okay. Actually, you know what? Let me get rid of this. Let me get rid of that inside one. Yeah, let me get rid of that. Exit. Exit. Pad it. Up, up, up. Okay. On that face, I will sketch. You can shell it, but there's something called shelling, but I'm not going to do it. I'll do it the long way. When I say shelling, I don't mean shell elements. There is something called, let me show you this icon. This guy, where is it? Right there. See that? Shell. Okay, so you carve out stuff, dress up features, but I'm not going to do it like that. I'll just pocket it. Okay, just pocket it. So I'll pocket this thing. Not all the way, maybe 3. So it's, something like that. Now, on that face, I will sketch a circle. This is where the hole is, the virtual bolt is going to go. Exit. Pocket. Maybe 0.5. Let's see how it looks like. Yeah, okay, that's good. Okay. And I do exactly the same thing on the other side, which means I can mirror this actually. So let's find a mirror. Where is the mirror operation? It's on the transform right there. I think it's this, yeah. Mirror that hole with respect to this. Okay, on the other side. Okay, so this is going to be the container. And then I'm going to insert cap. Insert a new part. This part 2 is going to be the cap, okay? I can call it right-click properties cap. Okay, no problem. Cap and cap. Let's make it. All right, so what I'm going to do, I'm going to do it the lazy way. I'm going to, on that face, I will sketch. I'm going to project that entire, excuse me, that entire face right there. Okay, exit and pad it. That's going to be the cap. I'll make it a little bit smaller, 0.5 maybe. Oh, I just realized that I didn't need this outside, this inside face, so I can go fix it. So let's go to that sketch. Yeah, let's delete the stuff that we don't want. We don't want this. We don't want that. That's why it made a opening there. And that one. Exit. Now it's good. Should be closed. Oh, there we are. Okay. Now remember, there are no constraints here. If I move these things apart, I'm pretty much dead meat. So let's go over here. Apply material. Everything is made out of steel. On that, we make it out of steel. We say OK. All right. And we go to generative structure analysis. Katia sees 2 parts, immediately meshes it, and that's, irrespective of whether the size of the mesh is reasonable or not, because these are small holes, these are small holes. It's a pretty bad mesh. Let me, just to be on the safe side, I'll make this thing 0.2, but still linear. You can see that. It's more respectable now. And this one also, I'll make it 0.2. But these are linear, so it's going to go very fast. Okay, if you want to see the mesh, right-click mesh visualization. It looks like that. Terrible mesh. You can already see. You can already see this circular hole became actually. But we're okay. You get the picture. Deactivate this. Okay, good. So what do we know? We know that these corner points are fixed. This is clamped. This is clamped. We are not using any planes of symmetry here, otherwise we have to use surface slider also, the right spot. Now we have to create a connection between the top of this cap and the bottom of the cap and the top of the container. So we click on it. For the first component, let me hide this. This guy. For the second component, the bottom of that. I don't want to select the surface. I think I got the right thing. I'm not sure. I'm pretty sure it is. Okay, good. Yep, that's fine. And this fellow is going to be contact. So we go to face-face connection property, second icon on the left, they cannot penetrate each other. Now I need two connections for these holes, top and the bottom, and we're going to make it virtual. So connection number 2. Okay, let's see if we can fix it here easily. Let me turn this thing around and more. So first component is going to be this surface. Second component is going to be the one below it. And this is going to be virtual type wall tightening, and same thing on the other side. So another connection between this second component, surface below it. Okay. And these are going to be right here in the distance connection property, this icon, it says virtual bolt tightening. So that one. And I don't know, I put down 50 pounds for this and 50 pounds for that. I mean, these have to be meaningful stuff. Right now, I'm showing you the process. And what is the load? The load is actually this can be pressurized, for example. But of course, we can run it now. We can run it. And these two are just tightened together. And you can see. So there we are. Okay, let's change the scale. Yeah, you can see that. You see? These are tightened, so it looks like that. Terrible mesh. Okay, so now deactivate this because I want to pressurize inside of this. So let me hide that guy, put a pressure on these faces, and let's actually make it a positive, not negative. Try this. Yeah, and that, and that, and that. We say okay. And we pressurize the cap. There is some technical issue involved here because there may be a gasket there. So right now I'm also putting the pressure on this edge, on these faces, on the side, but actually there's a gasket. It doesn't go on the whole thing. So let's go ahead and bring it in the front. Well, let's give it a try. So everything is pressurized inside on the cap. So run it. And done. So let's look at the deformation. Change the scale. There we are. That's what you expect, right? When you pressurize it, this thing basically expands. Usually there's a gasket that won't allow, you don't put that much pressure that you get a big gap like that. And then you can look at, for example, von Mises stress, obviously garbage in, garbage out. Be careful. So there we are. Okay, so what I have here for you is I did this. I want to finish this thing quickly. There are several videos from previous years where this is installed. I'm not going to be using planar symmetry. Okay, so please watch videos from previous years to see how this is done with the planar symmetry, etc. On the test, you will be asked to use all applicable planes of symmetry, so you should be able to do that. So let me quickly go and do this problem. and I'm going to ignore all dimensions. Ignore all dimensions. I just make something for you and load it, etc. So we start with a product file, insert, insert, new part in there. I'm going to call this thing left bearing. Okay, left bearing, left bearing, left. Okay. Remember, I'm not using any planes of symmetry. Okay. So on that vertical, make it on that vertical plane. I sketch on that plane. I sketch something that resembles that cross section, like this, like that. I'm going to clean it up in a minute if necessary. Okay, let's make it nice and symmetric. So this line control that line, control middle axis. Oops, this line control that line, control middle axis. We're going to make it symmetric, and there's a hole there. Exit, shaft padded. Yeah, that's good. Now we're going to do the right one. Insert, insert new part. I'm going to call this thing the right one. Properties, right, and right. Okay, let's make it. And I'm going to do it the lazy way. So on that face, I will sketch. Why don't I project that entire face? Okay, exit. There we are. And then pad it by the same amount. There we are. All the way to the top. These are two parts adjacent to each other, so I can use the move to translate it in the direction Y, for example, like that. Okay, now let's make the shaft. So all the way to the top, insert a new part. And this is going to be the shaft. I'm not going to rename it. I'll just leave it the way it is. Okay. So on that, let me be lazy. On that face, I will sketch. You know what? Actually, let me do the following. Yeah, on that face, on that face, I will. First of all, we have to go into the shaft, trying to make it. Okay. On that face, I will sketch. Okay. A circle that size. So let me project that circle. Okay. Is it projected? I don't know. Did I project it? Yeah, that's. Let me try because I'm not sure. Project that circle. Oh, now it's projected. Exit. Okay, let me make this in 10 inches long. 10 inches long. Okay, good, good. Now, I want a little stand on this. I showed you in the crash course on this problem how to do that. There are other ways of doing it. So this is what I did. So I created a plate, a plane, not a plate, from this side in the other direction, 5 inches, which is going to be exactly halfway, right there. And on that guy, I sketched. Let me see. I sketched, something like this. Please go ahead and review that because there was more time spent on it before. So I drew something like this, and then I exited. So there is a rectangle there, and I shafted that about this axis. Okay, you can go and review it if you want. Finally, I put these things together. There are no assembly constraints, so you got to be careful. So this is already coincidence because of the way I did it. Coincidence between this face and that face. say OK, update. I'll do the same thing on this side. So coincidence between, you know what? Maybe I better fix anchor this, okay, and then do that. Remember, I said that you really have to review your stuff. We need very basic stuff for assembly constraints, but if you don't remember, you have to go and review it. All right, so let's make everything out of steel. Are we on the top? Yeah. Make everything out of steel. Apply material, which is somewhere here. Everything out of steel. It's done. And we go to generative structure analysis. No planes of symmetry are used, remember? Deactivate the plot. No, what I mean is change the rendering. It doesn't sound like deactivating the plot. The bottoms are clamped. This is clamped, and this is clamped. You put a pressure on the top, or some kind of a force on the top. Remember, if you're using symmetry, make sure that you appropriately divide that by the appropriate number. Let's say, I don't know, maybe 100 pounds, I'll put 1,000 pounds. Doesn't matter. Now I have to create a connection between these faces. So I need one that the shaft does not penetrate the base, left one and the right one, and on both sides. So a connection between the surface of this, and for the second component, hide that, and surface of the hole. I need another one for the other side. So another connection between this face, and for the second component, once again, the surface of the shaft. Okay, let's bring this thing in the front. And these are contacts, because shaft cannot penetrate this. So both of them are contact. Go to face-face connection property. Face-face connection property. Here is contact. This one is contact. It puts that icon there. And this one is also contact. You see that? The only problem is that if we run it, it's going to bomb out. You'll see why in a minute. Yep. Yes, it bombed out. You can see exactly why it bombs out. If you look at the deformation, you can see that actually the shaft can slide inside of those two holes. So here I'm going to make an assumption. I'm going to say, for example, let me deactivate this. I'm going to say, suppose we welded the edge of this shaft to the outside edge of this hole. So I'm going to create a connection. Let me hide this. The edge of the shaft, second component, the edge of this hole. So let me bring this in the front. I'm going to hide the shaft, the edge of this hole, and this last one is going to be fasten. Where is fasten? Face-face connection property, right here, the one next to the contact. Fasten means fully welded, or fully bonded, or perfectly welded. Okay, and let me bring this thing in the front so that you don't get confused. And now we're going to run it. So that stops the motion of this shaft inside that bearing. If it doesn't happen in real life, because there's significant friction between the components, but we are ignoring all friction effects. So there we are. Let me change the rendering here. Okay, and change this thing to material shading. This is the displacement. Okay, this is a displacement, and if you animate it, you can see what happens. Because this is welded to that, it makes this thing bend, but this, when it bends, it just slides out because these are not welded. If under this situation, there's only one plane of symmetry, namely YZ. If I had welding on this side and welding on that side, then there'll be YZ and XZ. And remember, then you have to take surface sliders and things like that into account. So this was, I went about 5-6 minutes overboard, but I have done. I'm done with all the stuff that I wanted to show you about assemblies in the context that you're gonna have a test on a midterm on it. Okay. Good luck.